Hello dear students, welcome to physics online session. So today we will be discussing about velocity time graph. So in last class we discussed the concept related to a position time graph. So in case of position time graph, so time is along x-axis we will take, and position of the object we will take it along y-axis here. So in that case, so we got that position time graph if the object is at rest position, and position time graph if the object is moving with the uniform motion. So in today's class, so let me discuss about that velocity time graph. So from the velocity time graph we are having applications. So before going to discuss about that application part, so first let me understand what is velocity time graph, and velocity time graph for different cases we will consider here. So let me start with the concept of velocity time graph. Velocity time graph. So first I have to understand what is that velocity time graph here. So velocity time graph means, so time is along x-axis and velocity of the object I will take it along y-axis. So such kind of graph I will take it as velocity time graph. So what is velocity time graph here? So time is along x-axis and velocity is along y-axis here. So such kind of graph I will take it as velocity time graph here. So what is that velocity time graph here, or in short form we can call it as VT graph here. So in case of that VT graph, so I will take that time is along x-axis and velocity of the object is along y-axis. Now we will look at that. So what are the different cases, means what are the nature of graph? So for velocity time graph, if the object is moving with the uniform velocity, or if the object is moving with the uniform acceleration. So look at here, velocity time graph means, so velocity divided by time taken, so that is acceleration. So VT graph will give the information about that acceleration, whereas position time graph will give the information position divided by time, or distance by time. So it gives the information about that speed or velocity. So remember here, position time graph will give the information about that speed and velocity, whereas velocity time graph will give the information about that acceleration here. So let me begin with the first aspect, so that is velocity time graph for the object moving with uniform velocity. So remember here, VT graph for an object moving with uniform velocity. So what do you mean by uniform velocity? So uniform velocity means, so equal distance or equal displacement in equal interval of time. So equal displacement in equal interval of time means velocity will be remains same. So I have to draw the nature of graph for that uniform velocity for VT graph here. So velocity time graph. So in case of that velocity time graph, so I will take that time is along x-axis here and velocity of the object is along y-axis. So then what is the nature of graph velocity, or nature of that velocity time graph for the object moving with the uniform velocity? So if the object is moving with uniform velocity means velocity of the object will be remains the same, or velocity will be constant here. So if the velocity is constant means y coordinate value should not get changes here. So as the time passage, y coordinate value should not get changes means, so this is the nature of graph. A straight line is parallel to x-axis, so when the object is moving with the uniform velocity. So remember here, I have to draw that velocity time graph for the object moving with uniform velocity. So in case of velocity time graph, so uniform velocity means velocity value should not get changes, y coordinate value will not get changed means a straight line will be parallel to x-axis here. So in case of position time graph we took that. So remember here, So just I will recall here. So this is time and this is position of the object. So what is the position time graph if the object is moving with uniform velocity or uniform speed here? So in case of that position time graph, so look at here, along x-axis you will take position, along y-axis you are taking, along x-axis you are considering that time here, along y-axis you will take that position here. So 1 meter, 2 meter, 3 meter for 1 second, 2 second, 3 second. So position or displacement in equal interval of time. So equal displacement in equal interval of time means, so this is the nature of graph or nature of position time graph if the object is moving with uniform velocity. So position time graph for the object moving with uniform velocity means equal displacement in equal interval of time. So position will be equal, change in position, so equal displacement in equal interval of time. So this is the straight line passes through the origin in case of object is moving with uniform velocity in case of position time graph. In case of position time graph, this is the nature of graph for uniform velocity. Velocity time graph for uniform velocity is velocity value will not get changes, so straight line is parallel to x-axis. So now let me consider that this velocity time graph for the object if the object is moving with uniform acceleration. So remember here, so next graph, VT graph, velocity time graph for an object moving with uniform acceleration. So look at here, I have to draw on that velocity time graph here. So remember here, velocity time graph. So time is along x-axis and velocity of the object is along y-axis. VT graph for uniform acceleration. So look at here, along x-axis time, along y-axis velocity here. What is that uniform acceleration first? So what is that uniform acceleration? In case of acceleration we discussed that. So uniform acceleration and non-uniform acceleration. So uniform acceleration means change in velocity in equal interval of time is constant. So along y-axis I will take that. So velocity here, velocity is 5 meter per second, 10 meter per second and 15 meter per second. For example, for 1 second, so 5 meter per second. For 2 seconds, 10 meter per second. For 3 seconds, 15 meter per second here. So 15 minus of 10, so 5 meter per second, change in velocity here. 10 minus of 5, again 5 meter per second. Here also 5 meter per second. So this motion is about uniform acceleration. What's that uniform acceleration? Change in velocity. So change in velocity means final velocity minus initial velocity. So for these two, velocity, this is final, this is initial, 15 minus of 10. For these two velocity, this is final, this is initial, 10 minus of 5. So change in velocity is same here. So change in velocity is same for equal interval of time. So such kind of acceleration is uniform acceleration. So origin, first second, 2 and third second, fourth second, like that. Sorry, here that 5 meter per second, 10 meter per second, 15 meter per second. So now we will draw on that nature of graph for this reading. So for 1 second, what is that velocity value? 5 meter per second. For 1 second, velocity value is 5 meter per second. For 2 second, what is that velocity value? 10 meter per second. For 3 second, so third second, what is the velocity value? 15 meter per second. If I join the points, look at here, again you will get that straight line. That straight line is passes through the origin here. So look at here, so I will redraw it. So this is the nature of graph velocity, or this is the nature of velocity time graph for an object moving with uniform acceleration. So I said that If the straight line is passes through the origin means, so that graph we can call it as linear graph here. So look at here, so this is linear graph. So hope you are understanding about that velocity time graph. So in last class we discussed about that position time graph here. So if you perfectly understand the definition of that uniform speed, uniform velocity or uniform acceleration, you may understand about that nature of graph. So this is the nature of graph, nature of velocity time graph for the object moving with uniform acceleration. So next we will consider here initial velocity is 0 here. So what is that initial velocity? Start from the 0, 5, 10 meter per second, so 15 meter per second. So this is the nature of graph for that uniform acceleration if initial velocity is 0. Suppose initial velocity of the object is not 0 here. So if suppose if the initial velocity of the object is not 0 means what will be its nature of graph I need to consider. So look at here, if initial velocity is not 0, so this is time and velocity. So if the initial velocity is not 0 means it interrupt the y-axis here. So this gap indicates that initial velocity. So the object is moving with certain initial velocity. It has some initial velocity. Initial velocity is not 0 here. So here initial velocity is not 0. So this is the nature of graph for that uniform acceleration if the object initial velocity is not 0. So if the object is moving with certain initial velocity. So if the initial velocity is not 0 means, so this is the velocity time graph. So now in case of acceleration we will look at that positive acceleration as well as negative acceleration. So I have to draw on that velocity time graph for an object moving with uniform positive acceleration and uniform negative acceleration. So look at here, next we will consider that VT graph, PT graph for uniform positive acceleration. VT graph for uniform positive acceleration. First of all, first I have to understand that what is positive acceleration. So positive acceleration means if final velocity of the body is greater than the initial velocity. So what is positive acceleration here? If final velocity of the object is greater than the initial velocity, so such kind of acceleration we will take it as positive acceleration. So what is positive acceleration here? If final velocity of the body, if final velocity of the body is greater than initial velocity. If final velocity of the body is greater than initial velocity, then it is positive acceleration. So what is positive acceleration here? Look at here. So if the final velocity is greater than the initial velocity, so then the acceleration is said to be positive acceleration. So look at here. So I have to draw on that velocity time graph for the object moving with uniform positive acceleration. So look at here. So this is origin. So object is moving from this point. So this is initial velocity. Point A is initial velocity. Point B is final velocity. So look at here. So from the graph, which value is greater here? So this is initial velocity and this is final velocity. So interrupt that y-axis here. So it is interrupt the y-axis here. So point A and here that point B. So which value is greater here? Initial velocity or final velocity? So final velocity value is greater here. Point B intercept. So at this point. So y coordinate value is velocity here. So final velocity is this point, initial velocity is this point. Which velocity is greater here? Final velocity is greater than the initial velocity. So such kind of acceleration is positive acceleration. So another one, I have to consider that velocity time graph for uniform negative acceleration. So remember here, negative acceleration also will call it by another name, so that is retardation. So in most of the textbook, so we will use that negative acceleration or retardation we can call, in other word. So look at here. So we'll consider velocity time graph, VT graph, for uniform negative acceleration. So negative acceleration also will call by another name, so that is retardation. So negative acceleration means retardation. So what is retardation or what is negative acceleration then? So look at here. If final velocity of the body is less than that of initial velocity. So look at here, what is retardation here? If final velocity of the body is less than initial velocity is known as negative acceleration. So is known as negative acceleration, also will call by another name, so that is retardation. So look at here. So what is a velocity time graph for uniform negative acceleration? I need to consider here. So let me draw the graph first. So time is along x-axis and usually velocity is along y-axis. So final velocity of the body is less than that of initial velocity. So look at here, object is moving like this. So this is the point A, so means initial velocity. That object starts its journey from this point. Here initial velocity is point A I will take, and final velocity is point B. So look at, by the definition, if the final velocity of the body is less than that of initial velocity, so this is initial velocity and this is final velocity. So y coordinate value at this point is less, so final velocity value is less than that of initial velocity. So look at here, point B intercept at this point. So final velocity is here, initial velocity is here. So which velocity is greater here? Initial velocity only greater, or final velocity is less than that of initial velocity? Such kind of acceleration is nothing but negative acceleration, or also we can call it as retardation here. So hope you